Okay, now, as per many of your requests, we're going to look at piecewise functions, and then tomorrow we'll have a worksheet surrounding these, okay? Little do you know that you have already been presented piecewise functions. When we talked about the graph of the absolute value of x, we defined it as piecewise. But now, of course, we're talking about functions, so we might as well now elevate this to the ranks of functions, okay, which it has deserved. F of x now is now this function, the absolute value of x, okay? And we know what that function is looking like because we know what our 7 deadly functions look like. And there it is, okay? That's our absolute value of x right there. I don't think anybody will argue with that. But now, okay, it is also defined as piecewise, which means, okay, it is a piece of two different graphs, okay? Two different graphs. So let me show you what that implies, okay? And hopefully I can do that with a little color scheme here. Let me just see. Okay, we're going to go with green at first, okay? Now, what I'm going to do is, okay, I'm going to meet this condition, okay, in green, which says that I want to graph, okay, the function y equals the opposite of x, which is going to, okay, that's a little off right there, so I'll just graph that going through the origin. So here is the graph of that guy, okay, but I only want up to 0. So in other words, I've got to effectively erase all this, so that's not really there. So I'm going to erase all that, and let's see, I think I can erase all that, but I'll come back and do that. Let me do now in blue the other condition. The other condition says, okay, it is the graph of y equals x when x is greater than 0. Okay, so when x is greater, so the graph of y equals x is right here, all right? But there again, I only want this condition where it's for x greater than 0. Okay, so what I want to meet both of these, and then basically I'm going to fill that in because that's a third condition, but it's already filled in. Okay, so now what this means is I want the green line only for the x values are negative, because that's what it says here. So what I have to do is I have to come down and I have to erase. Let me see, I can erase this. Well, that's what I thought. It's going to erase the whole thing. Let me just try to undo that, okay? And I want to erase just this portion of it, okay? All right, I get that out of there. That's out of there. Then I'm going to get, it's not going, okay? So what I have to do is basically find a way to erase that, and I'm not finding a way to erase that, but okay, if it was paper and pencil, it would be fine. So what I'm doing, pretend I didn't erase that whole thing, and what I did was just erase the half of it from here, okay? So I'm taking that portion of the green line and this portion of the blue line. So again, let's try to erase, okay? And see what happens. And of course I erased the whole thing, so I come back and show you there by hand now that this is, of course, I have the slope of 1. So there's the absolute value. Now, lo and behold, okay, your calculator can do the same thing, and maybe the calculator will do a better job of explaining it. So let's pull up the calculator, okay? Now we want to graph, okay, let's turn it on, and we want to graph the absolute value of x. Okay, now absolute value is in the catalog. It's actually the first line in the catalog. I've been all the way down the catalog, so I'm just going to hit key, hit A, and it goes right there. Gives me absolute value. So I want the absolute value of x. That's a command, and it comes up there. And no surprise, we know what that graph looks like, okay? We know what that graph looks like, right? Now, okay. Now, let me go and do something else now. Let me go and do the piecewise description for absolute value. So what I'm going to do here is I'm going to come up here to y equals, and what I can do is I can hide this y1, and that's hidden with the F4 command. So F4, you can see, will toggle a check mark on and off there. for in front of y1. So I want it off because I don't want to see the graph. Now, I want to see the the graph of y equals negative x, or excuse me, y equals the opposite of x. So let's put that in. So again, we have to key it in with this. This is the opposite key as opposed to the subtraction key. Okay, so I want the opposite of x. All right, and of course you're going to know what that graph is. It's just the graph that bisects the third and the second and fourth quadrant. Okay, but I want to put a conditional on that. So here's how we go and put our conditions on there. Okay, so I can come up back up here and alter this. Okay, so I'm going to get it into my menu here, down here, my down here. Okay, and I'm going to use this. This is the conditional. So this is going to say for effectively, and then I'm going to say for x less than 0. For x less than 0. So I'm going to hit the x. I got less than or greater than signs down here, as you can see. Okay, you can't see now. Okay, I got less than sign here. Get rid of that for you. Okay, right there. So that's second less than 0. Okay, now what you should see is just, if you will, a half a line. Not geometrically correct to speak of a half a line, but there it is. It's going to be effectively a ray. So let's take a look at the picture of that now. That should be the 1/2 of the absolute value, and there it is. Okay, now, all right, now we come in and we meet the other condition, and we actually have to, our calculator will not do piecewise functions, so we have to actually enter them as separate functions, but then we can put the conditions on so that we can see one unified graph. Now we're going to say we want the other half, of course, which is that, and again our description here is for, with that slash bar, x greater than 0. And now, okay, what we should see upon entering is that, okay, we just see the other half of the graph. Here it comes, okay? And that collectively, if we now turn on our y1, which is the absolute value of x, we'll see, of course, there is no distinction. So now graphing, you'll see that the absolute value is graphing. It's just graphing, superimposing itself right over that. Now, I'm going to come and take a look at a couple more, but that's, again, how we can enter the piecewise graphs into our calculator. We have to enter for as many pieces as we have. Okay, we have to write it as different entries right here. Okay, so now you say, well, what about x equals 0? Well, I can't really show a single point on this, but we would know that when this is graphed, okay, the value, the origin, is included. Okay, and now we're going to look at another, another one that we're going to draw from scratch. Okay, so this one is asking us to do this piecewise graph. Okay, x squared for x less than 1. All right, so we know what x squared is, and we can plot a couple points to, to be a little bit more precise with our graphs. It would help. Okay, so we know that x squared contains 0, 0, 1, 1, 2, 4. Okay, and over here is where we want to stop. So here comes our x squared graph. Okay, so there's our x squared graph, only up to the value of 1. Okay, and then from there we're going to, just for illustrative purposes, we're going to take over with the square root graph. Now the square root graph we know starts at 0, 0, but we're going to follow the flow and only take it out there. So that's that piecewise description there. Now actually I did not include 1, so the only way I can kind of illustrate that is by putting an open circle here at 1, 1. All right, and that's one of our piecewise. We'll do a couple more. Okay, now we're back, and we're going to graph a piecewise function with three pieces, okay? Three-piece piecewise function, okay? So one part of it is a line described as 2x plus 1, and that's only for x values less than -2. Then we have the unit circle, but that's only between -1 and 0. And then we have our absolute value graph, but that's only from 2 on out. Now, the piecewise graph description is always listed in order from top to bottom, the same sequence we're going in left to right on our graph. So, this will be the 2x plus 1 will always be the leftmost piece, and that will be the top piece listed there, okay? The bottom piece will be the rightmost piece, and that's how we want to be consistent with our labeling, with how piecewise functions are written, and in the eventuality that we have the graph and you're asked to write the description, you want to bear that in mind as well. Okay, so let's see. We have to graph the line 2x plus 1. Now, of course, we know how to graph lines, okay? But in this case, the best way to graph the line is just to plot points, okay? Because that's going to be a little bit the way we're going to get the precise graph. Okay, so we're interested in the x value of -2, which is right here, and we're going to assign -2 to our function, at least that where it's defined at -2. So it's so in other words, if I were asking you what is f of -2, you'd say, well, -2 has to go in here. Now, it's not actually going in there because it's not taking on that value, but we need to have a point to plot. So f of -2 would be, of course, 2 times -2, plus 1. So that's -4 plus 1, so that's equal to -3. So I have the point -2, -3 to plot. So -2 over 1 down 2, and over 2 and down 3. I have that point to plot, but I really don't want to include that point. So I'm going to put the open circle there. Now, I know it's going to go down, but I want to have the slope right on that. So the slope, of course, is 2. So the slope of 2 means, okay, if I move down 2, 1, 2, I'm going to move over 2. So I have another point here. And, of course, that I can now just draw with a straight edge and put an arrowhead on it to imply that it's going on forever. Okay. Now, I have next my unit circle. Okay. My unit circle now, I believe that's next. Yeah, the unit circle is going to include, okay, the value here at -1, but it's going to stop at 0. So I have this portion of the unit circle, and I'm including that value, and I'm including this value. Okay. Then lastly, my absolute value graph, which typically would graph from 0, 0, 1, 1, 2, 2, 3, 3, but I only want to start at the x value of 2, which is right here, and I do want to include that point, so my graph is going to look like this now. So this is going to be my construction of my graphical construction here. And having done that, I just realized that I was a little flawed here, because this was not a slope of 2 from that point. That was a slope of 1. So I want to go down 2 and over 1, okay? So the slope is 2. So it's down 2 and over 1, so put it about there, and then come and graph that line, okay? So that is my piecewise graph as constructed there. This is a piecewise which is not continuous. You see, you have chops, you have values for where it's not defined. So in some cases, we're going to ask you, what is the domain? Well, the domain of that, of course, is pretty much defined by right here. We have these gaps, so we know that it's allowed to go to -infinity, but then the -2, not inclusive, in union with, okay, bracket, -1, 0, and then in union with, okay, 2 to infinity. Sorry for that interruption, but there is your graphs of piecewise functions, okay? So hopefully that helps, and we'll do more of those tomorrow.